All right, so here's another demo of I2C, and let's see how we can communicate with this display, the SSD1305, using the Pico from scratch without having to download any libraries. We're going to use MicroPython for this, and let me switch to the data sheet so we can see how we're going to communicate. So this is the SH1106. It's similar to the SSD1306. They're both the same. So but I'm going to use this image as a way to explain it. So to communicate, we need to send 2 bytes at a time when we're starting communication. So we send a control byte, and the control byte has the 2 more significant bits, 7 and 6, the ones that you have to set. The other ones are ignored, and then you send data, control byte data, and that's the sequence you go through. And the bit number 7, CO, if it's a 0, it says that it'll consider the last control byte, so you won't have to resend it because everything remains the same. And what you're sending after that is data only, right? So you don't have to keep sending control bytes over and over. If it's a 1, then you're sending a control byte and data, and then you can send data if you want to. For bit number 6, if it's 0, then it's going to be considered as a command. And if it's a 1, then you will be writing to memory. And the memory is what displays on the display itself. So let's go to the command table so we can see the first thing we want to do is we want to power up the display itself. By default, display is off. So we have to set this bit, A4 or A5. So A4 tells you that to display whatever's in memory, and A5 just turns every LED on, or every pixel on the display. And AE turns the display off, AF turns it on. So let's send an A4 and an AF and see what that does. Okay, so let me switch to my work area, and we'll start by importing the time. Import pin and import I2C. Set up a class, call it SSD. Def, initialize the constructor, click support. The way I have it connected, I have it on port 0 of the Pico, and I'm going to be using GP17 for SCL and 16 for SDA. So we'll use port 0. We'll use frequency as well, defaulted to 400K. SCL will be 17 and SDA 16. Double check, 17 and 16. I2C requires an address. We'll set it later. Port, frequency, SCL, and SDA. It's SDA. That's it. Let's see what's connected to our Pico by scanning. So print devices. Self dev scan. Device. Let's see what this does. So we'll call it display. It will be SSD, an instance of SSD, and we can say display print devices. Run it, and done. So we have line 11, we have an invalid syntax, this thing. Run it again. So we have address 60. We'll set that to 60 here. So now that we have the address, we should be able to send commands to power on the display. So let's call this send command first. Self. A command is 2 bytes, like I said before, so is the command and the data. And we want a local variable because we want to send both of them in an array. So the first thing we're going to send is the command itself. We will mask it because only the 2 most significant bits are important, 1, 2, 3, 4. And the data or data we're sending. So self dev write to self address byte array, and this will be the command. Okay, so now we can power up the display. Now we can send commands. So dev power up self, and so like we said before, to power up, we need to send a control byte and a command. So to send a command, we have to make sure that bit number 6 is 0, and the first communication we send, bit number 7 has to be 1. So self send command, and the first command will be 1, 0, and then 1, 2, 1, 2, 3, 4. And then we send the actual command itself. I mean, this is the command, then we send the data. And the data will be A4. A4. We'll do the same for the other one. We don't have to send the 1 because it's the same command, so there's no point on doing that. We can just send zeros. And this one is AF to power on the display. And we should be able to test it. Power up. Okay, so when I run it, you should see this light up. This right here. Okay, so let's run it, and you can see a few dots, right? Because those are just memory locations or pixels that were left on, or they're just weird. When you power up, some of them are gonna be on, some of them are gonna be off, and that is because that's what's on memory right now. So if we put a 5 here, it'll just light up the entire display because it just turns every pixel on. But that's not what we want. We want memory, right? So A4, that's what we want. Now let's create a function to clear the display to either light up the pixels or turn them off. So def clear, and it will be self, and then we tell it if we want it on or off. So 255 will be on, 0 will be off. Okay. So to clear the display, go here, go to the example they have on the SSD1306. So the display consists of from 0 to 127, so 128 columns of pixels, and it has 8 pages from 0 to 7, and each of the pages is a page. So from segment 0 all the way to 127, and then each page has a total of 8 rows. So 8 rows times 8 is 64 rows. So this is a 128 by 64 display, and we can address each of the pixels by a byte. So if you send 255, all the bits will be on, so the entire 8 rows in this page will be set to on. If you send, let's say, a 2, then this pixel will be on and the rest will be off. So how do you plot a pixel? So the way this is done is you have 7 pages. This is page 0 all the way to page 7. So you just have to cycle through them. And then to address the columns, you send 4 bytes at a time twice, for the first 4 bytes that are the low byte, and then the second 4 bytes that are the high byte of how to address this column. So let's take a look at that. So here we're just going to loop. So for page in pages, not in pages, but in range, and the range will be from this all the way to let's say B7, B8. So B7, so we have to put 8. So it goes all the way to the 7, both of them. So now that we can switch through each of the pages, now we can set the page. So self send command, and the command will be, we're sending a new control byte, right? And a 0 because it's going to go to a command, not memory. 1, 2, 3, 4. And then we send the actual command itself, or the data. And the data will be the page. So the page. Then we send another command to specify the column. Command. And we're just going to send a bunch of zeros because we're writing to the same location to a command. And this one, it says that first we send the low bytes, right? And then the high bytes. So if we want to address this location, I want to be at the top left of my page, and I have to send 0, 0, 0, and then 1, 0 hex. So 0, 0, and then I have to send it again, and this one's going to be 1, 0. So that will take me to the beginning of my page, and then I can send a bunch of data to turn it on, right? So now I can say self dev write to. This is no longer a command. We're going to send a bunch of bytes. So it's going to be a self address byte array, and then we're going to send a 0 because we're already writing to it, right? And this time we're going to put a 1 because if you recall, a 1 on bit number 6 means that we are writing to RAM. 1, 2, 3, 4. And then we include whatever we're adding over there. So that would be the byte, right? Or the on. So that's it. Let's test it. So let's see if it works. Let's display clear. And we're just going to set it to bright, right? So if we run it and there's no errors, well, obviously there's always errors. Write to self-def write to address byte. Object has no. What is wrong here? Has no actual. Oh, it doesn't have an uppercase. It's just write to. All right, let's run it. So that didn't do anything. Let's specify a 0. It's still not going to do anything. So let's see. So we are looking through the pages, right? From B0 to B8. Let's make sure that everything is correct. B0, B8, and then we're setting the high byte and the low byte. And then we're writing this. A byte array. So let's just put, oh, it's already 255. Let's see. Page in range from XB0 to XB8. Self-command 1, 2, 3, 4, 1, 2, 3, 4. That is correct. Address byte array. What are we doing here? 1, 2 byte array. Let's see. On. Oh, I know why. We're only sending a single bit, a single yeah, single bit. So we want to clear the entire page. So we want to send on, um, what is it, 128 times, right? So we're going to have to say for I in range 0, 130, 128. Let's see. All right, so there it is. Am I mixing any pixels? I think I am. You put 29, 28. It looks complete. All right, so that's the that's clearing the entire display and clearing it by lighting everything up. So we put on equals 0. It will go dark. Oh yeah, I am missing one. So let me put 29. There you go. Okay, so now that we have this, we should be able to plot a pixel anywhere on the screen, right? So let's do a function to plot pixel self x. Let's put a 10, y equals 10, and then the color. So we'll just say color equals 1. So it's either color or actually you should say on equals 1. So that's the default. So same as before, right? We have to find out uh, which column and which row is going to fall in, and the row is going to be dependent on the page, and the column is just the column is going to be driven by x, and the page will be driven by y. So we have to split x into 4 bytes, 4 bits. So we'll say x low. This will be x, and we'll mask it. That's all we need, right? And is this what we need? Yeah. And then we need high. So for high, this is going to be slightly different. So they have to be integers. So it will be integer as well. And this will be x. We're going to push it 4 bits to the right because we only want those 4 bits. And then we're going to mask it with the same 0f, right? And last, we have to make sure that 1, 2, 3, that this bit is always on. 1, 2, 3, 4. Okay. The next one is the on the page, on the pixel. So the pixel is going to be y divide the remainder of 7 of y modulo 7, because we're going to be taking y, dividing it into the number of rows per page, and then the remainder will be the pixel that is going to be on. So that will be it. Then we need a page, and for the page, this needs to be an int as well. So it will be y minus x7 divided by 7. And that should give us the page. What am I missing here? I'm missing one more. 1, 2, 3, 4. 1, 2, 3, 4. There we go. Why do I have so many? Let's see if it's going to calculate correctly. Oh, it's minus, not equals. X minus the remainder of that. I want too many right there. Like that. Okay. So now we do the same thing as before, right? Now we're going to do this thing again. So we will set the page, and then we will set the high byte and the low byte. This is XL and X high. and then we can write the pixel. So we can say self, let's see if sending command will work. Command, and then we'll say B. Now we're going to put a 1 because we're writing to memory, if you recall. Right? A 1 means that we are writing to memory, no longer a command. So it will be a bunch of zeros, and then it will be the pixel itself. So it will be a pixel, and hopefully that works. So let's plug a pixel in the middle of the screen. So display plot pixel, and it's going to be 6432. Way off. It's in the middle, but it's way off. It's not the page is not correctly here. So let's see what we're missing. So, oh, I know. So the page is between these two, right? So B0 and B7, and we're not accounting for B, so this should be XB0. Let's see. So there's the pixel right in the middle of the screen. Let's see if you guys are able to see it. So there it is, right? So now that we have the pixel, we should be able to bounce it around the screen and see what it looks like. So to bounce it, this is what I used to do in QBasic back when I started programming many years ago. So I would just set X, let's say I put 30, Y equals 30 as well. And then we set increment X equals 1 and increment Y equals 1. We set a loop, true. And then here we can say display, not display, but let's say X equals increment X and Y increment Y, and then we check to see if X is less than, let's say less than 3, or less than 5, or X is more than let's say 120, right? Then we say increment X multiply minus 1, so it starts going in reverse. And we do the same for Y. Let's say 5, or Y is more than 50. Then increment Y is going to be multiplied by minus 1, so it reverses itself. And then we can plug a pixel. Display plot pixel. And we can say X, Y, and it will be on. So we'll just do it like that. We'll make a delay of 0.00, let's say 5. And that's it. Let's run it. Let's see what it does. And we have errors line 70 right here, or. And there's the pixel being plugged in, right? So you can see it moving up and down, up and down. Let's see if you can see it. Yeah, so let me make it a little bit faster, put another 0 here. And there it is. So the pixel being plugged, and it went off the screen somewhere. So why did it do that? So if X is less than 5 or X is more than 120, then we multiply increment X by minus 1. Okay, still going. Increment Y by minus 1. Okay, not sure what it's doing, but anyways, that's not what we want, right? We want to bounce a pixel left and right. So what we'll do is we can take this and put it here at the beginning and say on equals 0. And let's run it. All right, so that means that there's an error on the calculation for the pixel itself. there's an error somewhere here the way I'm calculating the XL and the Y for the pixel, the page itself. So this is likely incorrect, I think. So let me see. Yeah, this is incorrect. Um, is it? If this is right, oh, that is correct. Pixel's incorrect. So this should be, we want to take whatever it says here and move it to the left, the remainder of whatever the row is, and then it should display it. So let's run it again. And there's the pixel going back and forth, right? So there's the pixel in the middle, we plug it, this one here, and then there's the pixel bouncing back and forth. All right, so let me switch this. Can you see it? Yeah, you can see it. So there's your little pixel bouncing back and forth. So let's take a look at the code real quick. So again, all you do is send a command, 2 bytes, right? Control pixel, control bits are 7 and 6. 6 is the important one if it's going to RAM or if it's a command. 2 minimum things you need to do is set up where the display is going to get its data and then turn on the display. And here, clearing the command, we're simply saying setting the page or looping through the pages, specifying the first pixel in the column, and then blasting it with a bunch of either zeros or 255s. And for plugging a pixel, it's the same thing. These are the commands. This is irrelevant because you can put whatever you want, but this is how you plug it, right? You specify the page, the column using this too, and then the pixel or the pixels that you're going to light up. So there you have it. The code will be in the the link to the code will be in the description, so you guys can download it and play with it, and have fun, enjoy.